with this probability, we have been able to see all the terminologies of probability. Now we want to work with probability by using a formula. Now, probability has something called a general formula that all of you must understand whilst you are solving probability questions. Even though along the line we'll learn new formula, but the general formula of probability, that is to say the probability of an event. So the general formula of probability is giving us probability is equal to the numerator will be the number of ways the event E can occur, all divided by the total number of possible outcomes, which is S. Now the formula has a mathematical symbol of P of E into bracket is equal to N of E divided by N of S, where the P of E becomes the probability of the event equal to the N of E becomes the number of ways the event can occur, and then the N of S becomes the number of total possible outcome or sample space. So once you have the event, if E is your event, then we are saying that probability of the event is equal to this N of E means that particular event you are talking about. How many ways does it occur? So that is why it is a number of E, that is the number of the event. How many ways does it occur? Now the next one is the number of sample space, that is the total number of occurrences or total sample space will be N of S. So this is the general formula for every probability. Now based on this formula, we are going to solve so many questions that will move to the laws of probability and to some specific events of probability. Now let me highlight this. Those of you who understand this very well, you must make sure that E is the general symbol for event. But if in case the question gives you a particular event, please use the symbol for the particular event. Choose your own symbol that will be very convenient. Don't still use the E. E is because we are talking about the general formula. At the right time, the particular name of the event, I will use an example to show you how we change the names. So let us take some examples on probability. In this question for the probability, it reads, a number is selected at random from the set S, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It says, what is the probability of selecting an odd number? So now it means that the event actually speaks about odd number. But before that, let's write a set. Now the set S, that is the number of sample space, will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means there are 10 number of entities or number of numbers in there. So our sample space will be 10. Now they are looking for odd number, but you see the probability of an odd number, that is odd for the event, will be equal to the number of the odd numbers. That is how many odd numbers are there divided by the number of sample space. Just we derive this formula by using the general formula. So let's go and look for the odd numbers itself. So odd numbers, the odd numbers. So from this, 1 is an odd number, 2 is not an odd number, so 3 is an odd number, 4 is not an odd number, 5 is an odd number, 6 is not an odd number, 7 is an odd number, 8 is not an odd number, 9 is an odd number, then 10 is not. So we have these as odd numbers. Don't forget, an odd number is any number that is not divisible by 2. That means if you divide it by 2, you will get a remainder in the form of a fraction or a decimal. So all these cannot be divided by 2, therefore they are odd numbers. So 1, 3, 5, 7, 9. We have 1, 2, 3, 4, 5. So the number of odd numbers will be 5. So that means that we cannot get a probability of odd numbers will be equal to the number of the odd numbers, which is 5, all divided by the total number of sample space, which is 10. Now 5 over 10 can still be broken down. 5 goes into itself 1, goes into 10 2. So we get 1 over 2. So the probability therefore becomes half. So you should know how many of the event you are talking about. And here in our case, the event was odd, and the number of odd numbers were 5. So making the event 5. So the number of odd numbers divided by the total number of sample space, and then the total number of numbers we talked about was 10. So the total number of sample space was rather 10. So this is the answer, 1 over 2. Thank you very much. This question reads, a number is chosen at random from the set of numbers from 1 to 15 inclusive. Find the probability of getting I, an even number, II, an odd number, III, a prime number, IV, a number less than 7, and then V, a number greater than 14. Now, with that, we know that it's 1 to 15, so the set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Please take note that it stated clearly that inclusive, that means 1 is part and 15 is part. If you count, we'll get 15. So the number of sample space or the total number of entities becomes 15. That means that we need to get the probability. The first one says I, probability of getting an even number. So if you want probability of even number, so even number, we need to get the number of even numbers, all divided by the number of sample space or the total number of possible outcomes. So the even numbers themselves are 2, 4, 6, 8, 10, 12, 14. So the even numbers are the numbers that are divisible by 2. So we have 2 itself, 4, 6, 8, 10, 12, making 1, 2, 3, 4, 5, 6, 7. 14 is also part, so 7. So probability of even numbers will be equal to 7 out of 15. So now the probability of the even number will be 7 out of 15 because we have 7 even numbers. Then let's go to II. Now II says odd number. So probability of odd. So probability of odd number will be equal to the number of odd numbers up here. Now let's see how many odd numbers are here. Odd numbers are numbers that are not divisible by 2. So 1 is an odd number. 3, 5, 7, 9, 11, 13, and 15. So they are the 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 odd numbers. So 8 out of 15 numbers. So the number of odd numbers up here, and then the total number of numbers, which is the 15. That is how it's supposed to be. Now let's go to III. Now we have prime numbers. Prime numbers are numbers that are having only 2 factors. That is 1 and the number itself. So probability of prime numbers. We need to get the number of prime numbers up here and the total number of numbers. So if we check the prime numbers, 2 is a prime number, so 1. 3 is a prime number, so 2. 5 is a prime number, so 3. 7 is a prime number, so 4. 11 is a prime number, so 5. 13 is a prime number, so 6. So there are 6 prime numbers there. 1, 2, 3, 4, 5, and 6 prime numbers. So let me just put the prime numbers down so that you see them. The prime numbers are 2, 3, 5, 7, 11, 13. If you count them, there will be 1, 2, 3, 4, 5, 6. So there are 6 out of 15. So you have 6 out of 15. Now this one we can reduce it. Now 3 goes here 2 and 3 goes here 5. So 2 out of 5. So the probability of finding prime numbers, we'll get the final answer as 2 out of 5. Now let's go to the IV. IV says a number less than 7. And if you check number less than 7, that means that a number that is not even up to 7. So numbers that are lesser than 7 will be 1, 2, 3, 4, 5, 6. Numbers that are lesser than 7 will be 6. So P of numbers less than 7. We get 6 numbers out of 15 numbers. So 3 goes into 6, 2. And 3 goes into 15, 5. So we'll get 2 over 5 for that. Then we go to the last one, which is V. It says the probability of numbers that are greater than 14. So P of numbers greater than 14. So greater than 14. Now we get that one. How many numbers are greater than 40? Only one number, which is the 15. So greater than 40, we have only one number. 1 out of 15 numbers. So the top part will be 1 and the down part will be 15. So this is how we solve all of them. Please, if you are not sure of how many they are, list down the particular 10. For example, they talked about even numbers. You list down all the even numbers before you count and then you put the number there. The same applies to the odd numbers, the prime numbers, and all the other numbers in the question. So this is how we actually solve the question here. Thank you very much. In a class of 50 students, 20 of them are boys. If a student is chosen at random, what is the probability of choosing a girl? So this is clearly a probability question because the question has asked us to get a probability of choosing a girl. The word probability has made it a probability question. So let's analyze. Now there are 50 students, so the number of students in the class, which becomes the number of sample space, is 50. Then the number of boys, so number of boys becomes 20. Since there are boys and girls in the class, then the number of girls will become 50 minus 20. Then we get 30 as the number of girls, because we're not giving number of girls, so we can use the information given to find the number of girls. Now probability of girls will be number of girls all divided by the number of sample space. So the number of girls is 30, the number of sample space becomes 50. So we cancel out and we get 3 over 5 as the final answer. So that means therefore the probability of finding girls becomes 3 over 5, or the probability of choosing a girl rather. So this is the probability of choosing a girl becomes 3 over 5. That is the final answer for this particular question. This question reads that a box contains 42 identical marbles. 12 of them are green, 15 of them are red, and the rest are white. Find the probability of selecting at random a white marble from the bag. So in this question, the bag contains 42 identical marbles. So the number of sample space becomes 42. Now it goes on to say 12 of them are green. So number of green marbles, J for green, number of green marbles becomes 12. And then 15 of them are red. So number of red, R for red, is equal to 15. Now, and the rest white. The rest means that we have to add these two and subtract from 42. So therefore the number of white marbles, that is N of white, that is white, W for white, is equal to 42 minus 12 plus 15. That is to say you will add 12 and add 15, then you subtract the answer from 42. So it will become 42 minus 12 plus 15 is 27. So we get 42 minus 27 is 15. So the number of white marbles will be 15. Now it says that find the probability of selecting at random white marble from the bag. So the number of white marble is 15. So probability of white marble will be equal to number of white marble all divided by the number of sample space. This is a general formula for probability, and because it's general, the number of white marble was given as 15. The number of sample space is given as 42. So it becomes probability of white marble is equal to N of white is 15, and then N of sample space or number of sample space becomes 42. So the answer becomes 15 over 42. So therefore the number of white marbles becoming 15 with the number of sample space, so they cannot cancel each other. So we can now say therefore probability of white marble will still be 15 over 42. The fraction is preferred, but you can also convert it into decimal. So the final answer for the probability of white marbles from this question is 15 over 42. That's the final answer. Thank you.